Well, hello everyone. On the bench today we have the Heathkit model IT-28 capacitor checker, and I thought we would go ahead and go through this piece of equipment and get it working. And now that Mike has sent us a good eye tube for it, we can go ahead and see what we can do. Now, I had one of these a while back, and I made the mistake and ended up giving it to someone that was in need of a capacitor tester. He works on old tube AM FM radios, and he needed something to check his capacitors and transformers and various things with. So I went ahead and gave that to him, and I shortly found out that I really could use another one. So I went online, started looking around, and man, the prices of these things has just gone outrageous. I have seen them up over $300 now. So a friend of mine went to a ham fest, and he came back and he picked this one up for about $25. And it looks to be pretty much original. Got a set of test leads with it. One thing that I will do later on is change out these banana jacks to a better quality. And if these are working, there's nothing wrong with them, but the thing is that this stud and the insert is aluminum, and any corrosion gets in there will cause these things to bind up and no longer function. And I've seen them before where you had to take a pair of pliers just to screw them off. They get so bad. So we'll probably change these out later on. I have some nice new ones like this, but the hole in these are way too big to fit in the existing holes. So I'm gonna have to get online, look around, try to find some good ones to replace these with later on. Now, I've said many times before, and a lot of times there's just no need, if you're working on a piece of vintage equipment, replace the capacitors. There's no need to test the capacitor to see if it needs to be replaced. You just go ahead and replace the capacitor. And the honest reason that I like to check capacitors out of a circuit is to look at the health of that circuit that capacitor was in. If you look at a capacitor and it's real leaky or shorted, what caused the problem? Was it the capacitor itself, or was there something else in that circuit that caused that problem? And this is where something like the IT-28 or even the solar unit or the night unit that I have comes in handy for doing. Just to actually get a idea of what happened in that circuit, what caused that capacitor to fail. And we're going to replace it anyway, but it's always good to know stuff like this. Now, this unit's not in too bad looking shape. There is some pitting on the front of it, which I know that is not going to come off. And you can see the little spots here. And what it is, this was rust that's gotten behind this and it's pitting the paint. Hopefully we can clean it and stop it and won't go no further, because trying to re-silk screen the front of this thing would be impossible. And it's got all the knobs on it. All the knobs look to be in pretty good shape. Just all needs cleaning. A little indicator pointer here is in good shape. The case is, a little bit scratched up and has some oxidation on it, and has caused it to flake off. So we'll take the case off, we'll clean it. I will not sand it down because I like to try to keep the wrinkle, and what we'll do, we'll just clean it and rough it up just a little bit, and then go back and respray it with some brown equipment paint. and that should make it look good again. So we'll go ahead and tear into it and see what all needs to be done. But before we do, the reason why I knew it needed the eye tube was when he brought this thing in, I went ahead and checked it. We powered it up. You can barely see the green glow of the tube. So I went in and I changed the resistor in the grid, which, you know, brightens up the tube a little bit, and the tube is just spotty all around. I mean, it's got places on it where you don't even see any green in there, so we know that tube is definitely gone. So we'll go ahead and get this thing opened up and take a look on the inside. So to get in this unit, all we do is remove these two screws in the back. As you can see, it came from, well, I'm not going to say came from the factory, but it was provided by Heathkit with a 3-wire power cord. And unfortunately, someone has broke the ground off of it, so that doesn't serve a purpose. I don't know why people would defeat stuff like that, but they do. So we'll go ahead and pull these two screws out. And man, I can tell the pollen is kicking up outside today because my throat is a little bit irritated and scratchy. Allergies are really tough sometimes. We should better pop this thing right open. And the inside of the case is very dirty. We'll have to clean that up. And you can see we have the original capacitors over here on the eye tube, which is the 6C5 with a 6AX4 tube. We'll need to check that out and make sure it's okay. There's a 6B N8 tube. We'll get that cleaned up and checked it out. See, some of the paint has gone off the transformer, and she's very dusty inside. But everything on this side looks fairly original. Now the other side, we can see somebody has replaced these two capacitors up here, and they've replaced them with 100 microfarads at 350 volts, which is a no-no. This circuit requires two 40 microfarads, and these are in series with each other. So 240 microfarads in series, and that's going to give you 20 microfarads. They've got 200 in series, which is going to give you 50 microfarads. So that's going to load the system down, you know, quite a bit. Voltage ratings are probably, you know, so-so. I think it's supposed to be, what, 150 volts? Oh, excuse me, 350 volts. So yeah, the voltage rating is fine, but the capacitance is just way too high in this circuit. So we'll get these poured out and get some good ones put in. We'll need to go in and check all these resistors, especially the high value resistors, and make sure that they are in tolerance. And those carbon current resistors will drift off in time. You see we have some precision resistors down here under the range switch, and a couple of capacitors. There's a micro capacitor down here. So we need to get all that checked out and get these switches cleaned up, and these potentiometers. and just see how he is. It doesn't, you know, it really not a whole lot to have to do in these. You know, mostly just replace the capacitors, check the resistors, and clean everything, and she, you know, should be good to go. Alright, the first thing I want to do, I went ahead and wiped everything down and tried to clean it the best I could. You know, it's not going to come but just so clean inside, but you know, it'll be fine for what it is. All the dust is wiped out of it. I went through it with some cleaner and wiped everything down and got all the cracks and crevices that I could. So the first thing we do is go ahead and get these old capacitors here. We got a 0.5 at 200 volt and a 0.1 200 volts. So we'll go ahead and get these out of here and get some new ones installed. So a 0.5. And there's our 0.1. I'm gonna get a little spaghetti tubing and put on these. That way that those leads that'll be coming down here will not have any chance at shorting out on anything. Alright, so we got these old ones here out. They're like a ceramic paper cap. A brand new 0.1. Put a piece of tubing on it. We ain't have to worry about the other end because it's going to ground. Yeah, I found some smaller tubing. And you know, we have our capacitors marked for the 4 side. Now most of the time they'll put the leads just through the hole here. Let me see if I can zoom in on this a little bit. They'll just stick the lead through it and sort it. I like to stick the lead through and then bend it out just a little bit. That makes for a little bit better mechanical connection. And we can stick our resistor lead back in that hole with it. It makes it a little tougher for the next person to work on it, but hopefully that will be down the road a ways. Okay, put that one in place. We'll take our 0.5, see where it needs to go. Alright, let me go ahead and solder those two ends. So I'm still playing around with my new software for video editing. And I don't know, I may use it on this video, we'll see. Just depends on how much time I have this afternoon. Alright, so those two new caps are in place. No problems there, so now we can go ahead and get the ground lead on each one of them. I'm going to move this back. You can see that capacitor's right there in that screw hole. I don't want that nowhere near a screw, so we'll just push this back to the back of the chassis here, and this way it completely misses that screw. Plenty of room in there anyway. I'll go ahead and get the ground lead soldered up. Alright, there we go. Our first two caps are been replaced. And we do have another capacitor down here. This big square capacitor. Looks like a 20 microfarad. I've tested this, it tests good. I'm not going to bother replacing that. I do not see these fail a lot, so we'll just let that one be. And we'll get on over here to the other side and get this abomination replaced, and get this one capacitor down here replaced. So these are supposed to be 40 microfarad at 350 volts. I do not have any 40 microfarads in stock. What I do have is 47 microfarad, which is fine to use. Remember, these two capacitors are in series, so it's going to be half the total of both. So we're still going to be somewhere close around 20 to 23 microfarad. And we'll go ahead and get these out and get our new ones installed. We just need to remember our polarity. Negative up here, positive at the bottom. This one should go, this is bridged across here. This should be our positive, and our negative should go down here to this center terminal. And we'll go ahead and get these out of the way. That was easy. You got mail. Come on. There we go. Alright, I'll go ahead and get all these holes cleaned up so I can get the new caps in. Alright, we got our two new electrolytic capacitors in the location that they were meant to be in. And now we need to move on down and get this 0.05 microfarad capacitor replaced. And get it out of the circuit and go ahead and get our new capacitor in there. And if you're wondering, these capacitors came from Just Radio. If you haven't heard me mention that before, that's where I mostly get all my capacitors from for these vintage equipment. So I'll go ahead and get this one out, and then we'll get through here and we'll start checking some resistors and seeing how they look. Okay, the last cap is installed, and first thing we're going to do is just going to start on this side, and we're going to start looking at these high ohm resistors and see if any of them's out. So I went ahead and took the old 6E5 tube out. Got a multimeter here. We're going to come up here and check this resistor. That was cross pins 2 and 4 of the tube. Should be 1 meg. 1.5 meg. So you can see she is out of tolerance pretty bad. And I happen to have some new old stock half watt 1 mega ohm resistors. So we'll go ahead and get one of those put in. So I happened to look on the screen and saw an icon flashing, and ended up having to delete about 27 gigabytes off this camera. That's how full it was getting. So I was running out of space. Anyway, I got the new resistor here, and we'll go ahead and check it just to make sure it's in tolerance before we put it in. These resistors has been here for quite a bit, and we at 1 meg, so that resistor is fine. Well, so far the only resistor that had to be replaced is this 1 mega ohm on the back of the I2 socket. So we got that one replaced, and down here under the bottom there's some precision 20k and 200k resistors, and they all check fine. Come around to this side and check quite a few resistors, and not finding no other problems. So we should be good on that. One thing I do not like is this big old sand block resistor, the ceramic resistor, just hanging off this switch. I know it's been like that for years and years and years, but just sitting there vibrating and flapping around in the breeze, it can eventually break these tabs off of this phenolic wafer switch. So I might look at doing something with that. I'll have to look it up in the circuit and see. This is a 10 watt 10k ohm resistor. I'll have to look at the circuit and see if there's any way to lengthen the leads on it and get it so it can be stationary, so it doesn't vibrate around. Maybe we can come up with something for that, because I actually do not like it just sitting there flapping around like that. Something else I need to do is order some more safety caps. I am completely out. Up here on the top you can see there's a couple of ceramic disc capacitors across the line cord. I'd like to get those replaced with some good quality safety caps. I should have some in next week. But probably the only thing else to do right now is go ahead and clean all the switch contacts and the controls and make sure they're in good shape. Got quite a few of these wafer switches here. This one here in the middle on the range switch. So we'll go ahead and do that next. So on the back of these controls right here, they're pretty much sealed up, but they did leave us a little hole in these to clean them with, and I'm just going to use some Deoxit D series and get a little shot in there. Work that control back and forth. And what that little hole is the indent that is actually the stop for these controls. And that should take care of those. Now, I'm not going to take this and just spray this, because like I say, this is phenolic, it's porous, it can soak this stuff up and later on start to crumble. So we do not want to do that. So the way we're going to clean this, you can see right down here, there's one of the little fingers is sticking out. You see it move back and forth there. So all we're going to do, get this thing so it doesn't wiggle around so much, we're going to take some D100L, put on that little tab, work it back and forth. Same thing on this one on this side. And we'll get under here to the long wiper. Do the same thing to it. And that should have that control pretty cleaned up. We'll come over here and do the same here. And I'll revive those contacts. And now the same to the voltage range switch. Okay. Like I say, I do not like spraying phenolic material with cleaner and letting it, you know, soak that stuff up in there, because these things are 40 years old, and like I say, they are porous. Okay, I'll go ahead and do the range switch up front here. It's going to be a little tougher to get to, so I'll do it off cam. And the same thing for our tubes. We'll just put a little bit on each pin. And we'll run this in and out a couple times. It should be good to go. And we'll do the rectum fryer the same way. The tube actually doesn't feel like it's making a good contact. It's kind of easy to pull right out. I'll tell you what we're going to do. We're going to come right around to this side. You can see the terminals for the tubes. We're going to just take our needle nose pliers and give them just a slight little squeeze. That'll retension those things just a bit. Like I say, you don't have to squeeze them hard, just a little bit. But I got that one too good. Now let's see how our tube fits in there. Much better. Yep, that feels a lot better. So we'll go ahead and install our new I-tube. That Mike provided us. And I don't want to get those oils from my hand all over the tube. Oils can cause hot spots on the tube. I'll go ahead and take it, just wipe it off, just to make sure there ain't no oils already on it. Good tight fit. And we'll adjust that just off the front plate. Okay. Now she's ready for testing out and calibrating. Okay, so now we got to go through the calibration process. And if you notice, we haven't even went to the manual on this thing, but most of it, you know, we just know what out of our head. It's not nothing hard to do. We're going to place a 100k ohm resistor across the test leads. Make sure that when you're doing this, you have the lever in the discharge position. If not, you are going to get a nasty little bite. So you know, just be very careful with that. You know, if you're following along, you're doing so at your own risk. Do not want to see anyone get hurt. Anyway, we're going to set the voltage up to 300 volts, and we're going to set the switch down to leakage. And what we want to do is get the eye to just close. So let me reposition the camera. Cut this light off. The eye is very bright, but it kind of washes the camera out just a little bit. And we're going to use the 3 controls that are here. We're going to start with the top one. I still don't like the way that is looking. I guess you can see it now. So we're going to rotate this to it just closes. And it just closes. So we'll go back to discharge and it should open, and it's open. Alright, next we're going to remove the 100k ohm resistor. And we're going to put a 1.5 mega ohm resistor into our test lead, and we're connecting directly at the banana jacks. You do not want to use any leads for the calibration. So we're directly on our banana plugs. This time we're going to go to 25 volts. We want to be on mini electrolytic or mini lytic, and we'll go to discharge, and our eye is almost closed. You can see that little slither in there. We're going to go to the bottom control, and we're going to adjust it so the eye is just closed. And what it is, when you adjust it, you want the eye to just touch and fill that little void. Okay, we'll go back to discharge. Okay, we're now going to set our controls to voltage at 3 volts. We want to go to paper. We're going to leave the same resistor in. On our last adjustment, we adjusted the bottom control. And we'll go to leakage and adjust the middle control. This will be the AC control. And you can see it's already completely closed. So we'll open it up and we'll turn it, and it is just closed. And that completes the calibration. Always make sure you, whenever you're doing anything, put this thing on discharge, turn the voltage all the way down, and this way you do not have to worry about getting bit, because that is no fun. Okay, so I tried checking the capacitor and got absolutely no reading, even from a bad capacitor that I knew was very leaky. No reading whatsoever. So something is going on with the high voltage. Let me turn my other light back on here. So it looks like we don't have any high voltage on the test leads. So we're going to have to go and look at that and see if we can't figure out what the problem is. So looking here at our schematic, we can see our rectifier tube. and that's the two electrolytics we replaced. So we should have a 600 plus volts coming down on this line, and then coming right over here to the voltage select switch. Somebody just replied to YouTube. So we should be able to find our high voltage here, and we'll need to come down here to our voltage select switch and see if we got voltage there. And then, you know, it's going to be resistors that drop the voltage all the way down to 3 volts. So if we got voltage here, we should have voltage all the way around this, and then out to the bridge charge, discharge and leakage switch. So this is the first place we need to check. It's from here and here, and then through these resistors to see if we have our voltage. So at this point right here, we should have our 600 plus DC volts coming out of the tube here. And we'll verify that. We'll go to ground, and we'll check here, and it's about 685 volts. So now we can follow this white wire right on over, and we can see where it goes down to our voltage select switch to this 2-watt resistor here. And I'll zoom in on that so you can see it. The 2-watt resistor is right here. So we need to check and see if we have our voltage there to make sure it's not a break in that white wire. And 684 volts. So now if we go to the other side of the resistor, we should have a voltage drop. And we're only seeing millivolts. There is no voltage on the other side of that resistor. So it's possible that resistor is bad, or there's something that is shorting out and causing that not to work. Alright, I'm going to go back to discharge. We'll desolder this orange wire and then check again. That orange wire is the output of the voltage selector switch. Okay, as you can see, I have the orange wire disconnected. If there was a short in this wire on the output of this, these resistors kind of act like current limiting, so it would show no output. So it's disconnected, and we'll okay, you can get it straight up to 600 volts. We'll go to that terminal, and we have 600 volts out. So we'll go down, and immediately on the 500 volt range there is nothing millivolts. We'll check the other side of the resistor. And I see nothing. So I'm going to discharge it, turn the unit off, and we'll need to check that resistor. And that is showing open circuit. Okay, so I had to take the switcher loose, and rotate it around so I could get this resistor out. And we take a look at it. We can see it's completely open. Now let's see if I have a 22K at 2-watt resistor. Okay, let's go ahead and check it. Resistor's installed. I'm on the 3-volt range. I think you can see the voltmeter from there. I'll go to ground and we'll check it. We at 2.6 volts, coming in a little low. Go to the 100-volt range. 103 volts. 3-volt range. 313 volts. 450-volt range. It's about 470. 600-volt range is about 660. So you can see it's now working just because of this one bad resistor that was in there, causing the voltage not to go through. And this thing is daisy chained around, so you know you got resistors in there that keeps dropping the voltage as it goes around. But you can go in and hand pick resistors and get it when you put it on 100 volts. It's dead on 100, dead on the 300, or whatever, you know. But it ain't really worth doing that, because you know, 20, 30, 40 volts is not going to really bother a capacitor. You know, if it's rated at 350, it's going to take just a little bit more. They're not going to put a whole lot more in it, but you know, only just because it is low amperage, and it's not going to blow a capacitor all to pieces. Now, if you got a 25-volt capacitor and you put a couple hundred volts in it, yeah, it's going to explode on you. So, you know, be very careful. So I'm going to have to realign this thing again and make sure everything is back to where it's supposed to be. And I'll go ahead and get this other wire soldered back on, and we'll give this thing a test. Okay, everything is readjusted and all back together. We have a I think it's a 0.1 microfarad at 25-volt cap. We'll zoom in on the eye a little bit. You can see that it's open. We'll switch over to leakage, and you can see at 3 volts it's trying to open. But yes, I would say that capacitor is leaky. Go up to 6 volts. Yeah, that capacitor is not even going to make it to its rated voltage. So we'll discharge. We'll take that one out. Put another one in here. Go back down to 3 volts. Leakage. You can see that one open. Now this is a 200 volt. 0.5 microfarad. In fact, one of the capacitors that came out of this machine. And you can see it opening right on up. That capacitor's not bad at all. Alright, we'll go to discharge. We'll grab another one here. Picked up a bunch of resistors with it. This is 0.1 at 200 volt. It's 200 volts. Discharge. This time we'll go to electric lytic. Got a 80 mic at 150. Don't think this one's going to quite make it. Yeah, that one's got a bit of leakage in it. Yeah. Yeah, 50 volts. She's not working too well. So there you go, guys. One old classic Heathkit IT-28 ready to go back in service. So hope you enjoyed it. It was very fun for me. I enjoy working on little things like this. It's very relaxing. We got the case all painted up, so that looks pretty good now. Went with equipment brown paint. So yeah, she's ready to go. Like I say, I'm gonna order some different banana jacks and put in there and get some good quality ones. Anyway, stay tuned. Plenty more to come, and we'll catch you in the next video. See you now.